Hi, welcome back. So what we want to do is continue with endocrine. We said my flat pig was the mnemonic of the hormones that are coming from the anterior pituitary. Let's take a look at some of the different types of hormones that we have. So we'll toggle back and forth. Hormones are classified into amino acids, and there are 20 amino acids. There's peptide hormones, and peptides and amino acids are both what we call polar. So they need some assistance in order to cross the membrane into the cell. Lipid derivatives or fat-like substances have an easier time. They can cross on their own through simple diffusion. So some of the amino acids that I want you guys to take a look at are tyrosine, tryptophan. Let's take a look at tyrosine. So tyrosine, I use a mnemonic, tell Denny. Tyrosine is converted to L-DOPA, L-DOPA to dopamine, dopamine to norepinephrine, norepinephrine to epinephrine. These three are considered catecholamines. Norepinephrine and epinephrine, another name for epinephrine is just adrenaline. So norepinephrine is also known as noradrenaline. These are three important catecholamines that you're going to see throughout medicine. Tyrosine is one of the 20 amino acids. It is converted to L-DOPA. L-DOPA is a drug that is given to patients that have Parkinson's. So Parkinson's is a disease in which you are deficient in dopamine production, and as a result, you see some of the symptoms like they call it pill rolling or tardive dyskinesia. So basically, they have difficulty with movement. It's not smooth movement, it's jerky. Dopamine is lacking, but one of the things that happens is the blood-brain barrier helps to protect the brain from any kind of substance that could enter into the GI tract, something that you eat, something that you drink, and preventing it from affecting the brain quickly. You have fat-soluble substances that can cross easily into the brain, and L-DOPA is one of those that crosses easily. Dopamine, on the other hand, is the thing that is deficient in Parkinson's, but because it's water soluble, it has a harder time crossing into the brain, and the rest of the body can use it. So what they do in medicine is they'll give L-DOPA. It crosses the blood-brain barrier because it's fat soluble. It enters into the CNS or the brain, and it is converted to dopamine, which is then used in the treatment of Parkinson's. So these are examples of amino acids. We also have peptide proteins. Most of your My Flat Pig is a Posa. Those are pretty much considered to be peptide or protein hormones. And let's take a look back at this image. Lipid derivatives, any of the steroid molecules, those have an easier time crossing. So could be fat, it could be cholesterol. In this case, eicosanoids or steroids. Let's skip through some of these and get ahead. Protein hormones, they are extracellular. So that means if I have a cell and I have a receptor found on it, normally fat substances, this we learned in 141, fat can cross on its own through something we call simple diffusion. That means it doesn't need any transporter. The membrane of the cell is made up of fat, so fat likes fat, allows it to cross. An example of fat could be something like cholesterol, it could be estrogen, it could even be testosterone, steroids, anything is fat-like, or small molecules like tyrosine. We said tyrosine was a really good one. Or I think they also talk about T3 and T4, thyroxine. So these guys can cross without any transport. What happens with protein is it needs assistance. It needs a button. So this is, let's say this is epinephrine. We just said epinephrine was one of the three catecholamines. And what it does is it triggers a second response. So they call this second messengers. And these second messengers will trigger some kind of activity. We're not going to specify what it is. It depends on the organ that we're talking about. So epinephrine is a protein or a peptide that is polarity or polar charge. It will trigger a button we call a receptor, which then sends a second message. So they call these second messengers. If you really want to know, this is extra information. IP3 and cyclic AMP are examples, really good examples of second messenger pathways. It activates some kind of activity, an enzyme, a protein, or some other cascade to do whatever job it's supposed to do. So let's move on. Steroids or thyroids, I said that they don't need any type of receptor on the outside. What happens is, unlike proteins, fats can cross in on their own and they end on a receptor, and the receptor is inside of the cell somewhere, or it could be inside of the nucleus. And what happens is a protein is then made. So there's the whole process of DNA, mRNA, right? Transcription, and then you'll have translation out here. Some kind of protein is being made. So the activity, if I compare epinephrine, which is a water-soluble drug or a water-soluble hormone, and fat, cholesterol, estrogen, testosterone, which is a fat-soluble substance, the difference between the two is epinephrine is fast. It's like pressing a button, turning on a light. The response is fast, but the effects are really short-term. So if I turn on the light, I can turn it right off. Immediate response. Fat, on the other hand, is because the button is on the inside, or the receptor is on the inside, my goal is to make a protein. The protein's job is to do the activity. The same as this one, but it takes longer to make the protein, and therefore longer for the effects to occur, but it also means that the protein lasts longer and the effects also last longer. Does it take a fast? Is it fast to make a cake, or is it slow to make a cake? Well, you have to make the ingredients, put them together, you have to throw it in the oven. So it takes time, but once the cake is made, it's there for a while, until, of course, you eat it. Let's move on. So these are some of the pathways, the difference between steroid and thyroid hormones. They're both intracellular because they can cross the membrane on their own through simple diffusion. Amino acid derivatives, tyrosine and tryptophan. So tyrosine, we said, was tell Denny. It's an important part of making epinephrine, norepinephrine, and dopamine. Tryptophan, on the other hand, is another important amino acid that we'll talk about in class. And tryptophan is great because it either becomes your sleep aid, which is called, so melatonin. Tryptophan is converted to melatonin. Melatonin assists with sleep, and it's associated with circadian rhythm. You have melatonin being made in the pineal gland of the brain. It can also be converted to 5-HT or serotonin. I like to think of serotonin as the happy pill. A lot of times when you talk about antidepressants, drugs that will help to resist depression, they talk about serotonin, SSRIs, which are selective serotonin reuptake inhibitors. That means there's more serotonin available, there's more happiness. Moving on. Peptide hormones, like I said, most of the MyFlat Pig is a POSA. Most of those hormones are examples of peptide hormones. And then steroids were the examples that we said were your lipid-soluble substances. Eicosanoids. Let's take a little look at what eicosanoids are. Two of the main classes are at the very bottom, prostaglandins and leukotrienes. They're associated with inflammation and the anti-inflammatory process. So leukotrienes associated with injury, disease, and prostaglandins. Two enzyme pathways. So there is one drug that I want you to know for class, and it's simply aspirin. It is what we call a COX inhibitor. I will test you on it. So COX-1, COX-2 inhibitors. Aspirin is a COX inhibitor, is one of the first ones made. It blocks the formation of your prostaglandins or your leukotrienes, and therefore is used to reduce inflammation. They call that an anti-inflammatory. It also helps to reduce fever and pain. Another COX inhibitor was actually Vioxx, which is pulled off the market, and Celebrex. Celebrex is what we call a COX-2 inhibitor. Same essential function is it acts as an anti-inflammatory. It is used in the treatment of arthritis a lot of times. So like I said, aspirin is a COX-1 inhibitor, reduces pain and inflammation. COX stands for cyclooxygenase. Steroid hormones. And let's take a little break for now.